So in this video, we're going to talk about how to sketch tangent graph, and also we're going to cover the solving for tan equations as well as solving the equation that have sine cos. And finally, we're going to talk about how to find the rule of the tan graph as well. All right, let's get started. Now, how to sketch tangent graph? So let's say our basic equation is y equal a with the dilation factor times tan of nx. Okay. Now, our first step is we going to find the asymptote of tan graph. So the asymptote is where whatever the x value inside here that make this pi over 2 because tan of pi over 2, so tan of pi over 2 is undefined. So that's why the reason if you make it equal pi 2 because tan pi 2 is undefined. So to find the asymptote, our first step is we let nx, so let nx, sorry, equal pi on 2. So we're on way to that. Then we solve for x, which is x equal pi over 2n. Okay, that's our first step. Then our second step is to find the other asymptote for tan. Sorry. We're going to find a period first, and then we're going to add a period into the asymptote to find other asymptote. So the period's formula for tan is pi over n, and n is right here. All right, so we're going to get other asymptote by adding a period from the original asymptote. So you have one asymptote here. You're going to write, let's say here pi over 2n, okay? Then to get other asymptote from it, what you do is you get a period here is pi over n. So you're going to plus pi over n to the original asymptote, and then you get the new asymptote here. And then to get the new asymptote, you just keep doing the same thing. You just keep plus a period. And you can also go backward as well. If you want to go backward, you just minus pi over n. Okay. So to find out the asymptote, we plus or subtract a period. Okay. So how does the tan graph look like? Just right here. So if we have, let's say, this is this scale, and then we have one of the asymptote here is x equal pi over 2n, right? If we plus a period, we get to the next asymptote here. So the middle between the asymptote will be somewhere here, and the tan graph will look something like this. Okay, and if you have the next asymptote here, then the middle, and then you just go the same type, and it just keep going on and on. All right, so this is if you didn't have any vertical translation. If I move my graph, so let's say if my tangent equation now have the vertical translation, let's say I have y equal a times tan of nx plus b or something. So if you do that, then the bay here affecting how much you move up and down for your graph, but the asymptote stay the same. It didn't affect the asymptote. So you would need to move up by bay here. So you have bay and then you move up, and then your tan graph will look like this now. Okay. And the A is the dilation factor. The A doesn't affect the asymptote, but it affects how thick, how thin or how wider your shape is. All right, now we're going to do an examples of how to sketch this one. So we follow the step given above. Our first step is we're going to find the asymptote first. Asymptote, which we're going to let to x here, we let to x, and we only let that equal pi 2. So if we divide it by 2 over, we get x equal pi on 4. That's our first asymptote. Then we're going to get a period. So the period's formula is pi on n. N is a number next to x, which is number 2, and we can see it here. So pi on 2. Okay. Now we're going to get other asymptote. So to get other asymptote, what we do is we start at pi over 4 is our one of our asymptote, and what we do is we're going to add a period into pi on 4. So if we do pi on 4 plus a period is pi on 2. Pound 2 is 2 pound 4, right? If we make them the same denominator, pound 4 plus 2 pound 4, that gives us 3 pound 4. That will be your next asymptote. And then you do the same thing. If you keep adding another 2 pound 4, if you keep adding the period, you get 5 pound 4, and so on. So you can see the pattern here: 1 pound 4, 3 pound 4, 3 pound, 5 pound 4. Now I look at my domain. My domain is negative pi to pi, which is you need to go on both sides as well. So pound 4, if you minus the period, if you minus 2 pound 4, you get negative pound 4. Okay, and then you would have keep doing the same thing, minus 2 pound 4, you get negative 3 pound 4, and then you have negative 5 pound 4 here. Now your domain negative pi to pi, so you wouldn't want these negative 5 pound 4 and 5 pound 4 on your graph. Okay, but remember that's still one of the asymptote. You can cut it off later. All right, so we're going to put them on the graph. So let me just delete this and we do it here. So what we have is we have all of the asymptote. We're going to write them down. So we have pound 4, 3 pound 4, so 2 pound 4 here, 3 pound 4. So the scaling is really important, okay? 4 pound 4, and this is 5 pound 4. It's not in the domain, but I just want to add in so I can show you where to cut off. And you have 0, you have 1 pound, negative 1 pound 4 here, negative 2 pound 4, negative 3 pound 4, and then negative 4 pound 4, and negative 5 pound 4 here, right? So be careful with the scaling. And then you're going to add in, so 5 pound 4 is the asymptote here, 3 pound 4 is the asymptote, 5 pound 4 is the asymptote, negative pound 4, negative 3 pound 4, and negative 5 pound 4. All right, now this one doesn't have any vertical translation, so I would start from the middle of each point on the 0 straight away. So you can see the middle between 1 pi and 3 pi, 2 pound 4. And then your graph will just go like this. Sorry, it's a bit not nice. And then you do the same thing for each of those one. Now, because you stop at pi, so this means you don't need to go further. Okay, so when you graph it, make sure that you only stop at pi here. Don't go any further than that, right? And then I do the same on this here. I have here, I have here. And then the same thing, you can see the graph look like that. We follow the mouse, but because you stop at negative pi, so it's only half of the graph. So it look like that. All right. For B, they pretty much the same thing, except that for B, if you have a negative 10 graph, so the 10 graph, this is positive 10 graph. Okay, so this is positive 10. If you have negative 10, your shape will be just upside down, really. It's reflection in the x-axis, so it's go like that now. All right. Now we're going to look at this one, which is a bit more challenging, sketching 10 graph, but this time we do have a horizontal translation. So our first step is we find the asymptote. And to get the asymptote, we do the same thing. We let whatever the equation inside of 10 here, we're going to let that equal pi over 2. So we have 2x minus pound 3 equal pound 2. And then we solve for x from here. So we plus pound 3 over 2x equal pound 2 plus pound 3. Make them the same denominator. You get 5 pound 6. And then get rid of the 2, divide by 2 on the other side. So multiply 2 here. So you get x equal 5 pound 12. Okay. Now, step 2 is you're going to get a period. So your period is pi over n, right? So pi over the number in front of x is 2, so pound 2. This means your asymptote. So you have other asymptote. You're going to have what you're going to have. You have 5 pound 12 as one of the asymptote. And then you're going to add a period into it. The period is pound 2. So you're going to plus pound 2, which is 6 pound 12. 5 plus 6 is 11 pound 12. Okay. And then keep going. 11 pound 12 plus another 6 pound 12. If you do the same thing, so 6 pound 12 give me 17 pound 12. So how do I know when to stop? So this is, if you look at the domain here, this is how you know when you stop. Because the domain here, they actually make it over 6 and your asymptote over 12. So we're going to make the same denominator to make it easier. So pound 6, if you times by 2, you get 2 pound 12. Less than or equal to x, less than 13 pound 6. If you times by 2, you get 26 pi on 12. This is how you know to stop the asymptote. So we have 5, 11, 17. Plus 6. Next, if we get 23 pound 12. And then if you plus another 6, you get 29, which is over the domain. Okay, but because I just added in for now, but I'm going to cut it off later. So can show you when to cut off, but we won't need this. All right, and then this is 5 pound 12. The domain is 2 pound 12. So if we go backwards, 5 minus 6 pound 12, you get negative 1 pound 12, which is just negative pound 12. But again, you won't need this sketch. You won't need negative pound 12. All right, so now we're going to put these asymptote on the graph. So I'm going to rough these out. And I'm going to do it here. Okay, so we have we have 5 pound 12 is one of our asymptote, 5 pound 12. We have 11 pound 12. We have 17 pound 12. We have 23 pound 12. And 29 pound 12 is not in the domain, but it's helpful to know where you should cut your graph. You should cut your graph at 26. Can you see that? And then negative pi on 12 will be on the other side. Again, you won't need it, but let's keep it for now. All right. So we have these will be our asymptote, right? Okay. Between the 2 points, between 5 and 11, you're going to make a middle number. 5 pound 12 and 11 pound 12. If you do 5 plus 11 divided by 2, you get 5 plus 11 is 16. 16 divided by 2 is 8 pound 12. That's how you know the middle. Okay. Now, because this is positive 10 graph and there's no vertical translation, so you will start on the axis straight away and it's go like that, right? And similar here, 11 and 17, the middle number is 14. When you finish this, you can simplify all the fraction later. And then this one will be 20 pound 12, and then it's go like this. Now 23 and 29, the middle is 26. and you look at your domain actually 26.12. So you know that luckily it's only your first half. Okay. Now -1 and 5, if you do -1 pi plus 5 pi is 4 pi divided by 2. So you know the middle is 2.12, which is exactly your domain on the left-hand side. And the whole graph will go like that. But because I don't want the left-hand side, I just want half of it. So it will go like that. Okay. And make sure you label all the point, the middle point, and then label the asymptote like x equal 5.12, x equal 11.12, and so on. And make sure you simplify the fractions as well. Okay. Now we're going to move to how to solve tan equation. So to get solve tan equation, pretty much similar to solving sine cos. We have an example here. So sine 3 tan of 2x equal √3. So what we do, we're going to move the 3 over by divide by 3 here. So we got tan of 2x equal √3 on 3, right? Then we're going to find the reference angle that have tan √3 on 3. Reference angle to that will be 30 degrees, which is pi over 6. We are doing in radian. Now we're going to draw a unit circle out. So we have a 30 degree of tan 6 in quadrant 1, right? So tan 6 is here. But tan, we're looking for tan positive. So as you know, we have a S, T, C. So the quadrant have tan positive is this quadrant and the quadrant number 3, which is pi plus 0.6, which is 7.6. So you're going to write here as 2x equal 0.6 or 7.6. And then you can solve for x by divided by 2. So down by 2 on the denominator. So x equal 0.12 and 7 pi on 12. Okay, how do we know if there's other solution? Now we look at the domain is 0 to 2 pi, right? So what we do is we're going to get a period for tan, and we're going to add in a period to those solution. That's how we can check if on a solution or not. So if I do that, I have a period is pi over n, and n is a number in front of x, which is 2. So period is 0.2. Okay, so I start with 0.12. So I have 0.12. If I plus a period is 0.2, because these are over 12, I'm going to make it 12 as well to make it easier, times 6. So 6.12. So 0.12, if you plus the period 6.12, you get 7.12. And you can see it's repeated itself here. Then you keep going, 7.12 plus 6.12, you get 13.12. And then 13.12 plus 6 is 19.12. 19 plus 6 is 25.12. But 25.12 is over your domain. Your domain is 2 pi. So you won't have that. So you end up having 4 solutions. The next one is pretty similar. You can see the example here. Here I have pretty much do the same thing. So 10 of the whole bunch of things give me -1. So I find the reference angle, which is the angle have tan equal 1 is 45 degrees, is 0.4. Then I draw the circle out. I look for tan is negative, which is ASTC. The quadrant have tan negative is quadrant 2 and quadrant 4. Okay, so 0.4 is here. In the second quadrant, it will be pi minus 0.4. You will have 3.4. And in this quadrant is 2 pi minus 0.4. 2 times 4 is 8, minus pi is 7, 7.4. So you're going to write whatever that is here, that's equal 3.4 and 7.4. So we have a half x minus 0.4 equal 3.4 or 7.4. Okay, then you just solve for x from here. So to solve for x, you're going to times, this is time by a half. So you're going to, opposite of time by a half is time by 2 on the other side. So to get rid of a half, we time by 2 here. So time 2, time 2. So we have x minus 0.4 equal 3 pi times 2 is 6.4 and 7 pi times 2 is 14.4. Then we get rid of the minus 0.4, we plus 0.4 on the other side. So it's 6 pi plus pi, 7.4 and 15.4. Now we have two solutions. We're going to check if it fit in our domain and is there more solution or not. All right, so let's look at our domain. Our domain is negative 2 pi to pi. Okay, these probably this one fit in, but this is too big. 15 gone to 4, 3 point something. Now, but the domain have negative region as well. So what we do, we're going to find a period and we're going to add in a period or subtract a period. Period is pi over n, and n is the number in front of x, as you can see here, which is a half. So pi over a half, when you flip it over, it's become 2 pi. Okay, so we have, let's make it more space. So we have 7.4 as one of our solution. If we add 2 pi, okay, 2 pi, if we make it over 4, 2 pi over 1, if we times by 4, it's 8.4. So 7 pi plus 8 pi is 15.4, which is exactly what we got here. All right, and but we don't want that because outside our domain. Now, if you go backward, if you minus 8.4, you would have 7 pi minus 8 pi is negative 1.4, which is in your domain. Okay. If you go again, if you minus 8.4, you get negative 9.4, which you don't want that because it's outside 2 pi. So you don't want that. And so you end up having negative 0.4 and 7.4 as your solution. All right. Now, let's talk about when we have solving sine and cos equation. So here we have here, you can see sine of 2x equals cos of 2x, and they actually solve it. So the general strategy is we're going to divide both sides by cos of whatever the angle is. So cos of 2x divided by cos of 2x on both sides. That's how we convert to tan, because remember, tan is sine divided by cos. Okay, so when we see the equation have sine and cos, we convert to tan by divide by cos both sides. So sine 2x divided by cos 2x, we have tan 2x on the left-hand side. Then we have equal cos 2x divided by cos 2x give you 1. And this goes back to a normal equation. You can just solve it. So the reference angle that have tan equal 1 is 45 degrees, right? So we have 0.4 in quadrant 1. And because we want tan positive, so ASTC, we want quadrant 1 and quadrant 3. So pi plus 0.4 here, that gives you 5.4. So we have 2x equal 0.4 or 5.4. And then you go to solve for x from here. So you have x equal 0.8 or 5.8. Okay. Then pretty much the same thing. You're going to get a period and you're going to check if your domain is having a lot more solution or not. So the period is pi over n is 2. Now you start with 0.8 and then you add in a period. So 0.2, if you make it over 8, will be 4 pi over 8. Pi on 8 plus 4 pi on 8, 5 pi on 8. So this is how we double check. We got that right. Now your domain go 2 pi, so you can keep going from you. So 4 pound A, keep pausing, you get 9 pound A, and then 13 pound 8, and then one more, which is 17 pound 8, but it's over 2 pi minutes, so you won't have that. So you end up having 4 solutions. Okay. All right. Now the last thing I want to cover is for the rule of the 10 graph. Sometimes they give you the some information and they ask you to find A and N, the unknown constant. All right. So how does that work here? They say they give you the equation and they give you the asymptote and they give you a point and they want you to find A and N. All right. So what does that really mean? So if you think about, they said K is integer, K belongs to Z, right? And the equation, the asymptote equation is 2K plus 1 pi on 6. So K integer, so K, if you think about any integer, like let's say K equals 0, if you sub 0 in, 2 times 0 plus 1 divided, 2 times 0 plus 1 pi over 6. That's the S1 of the asymptote. So you're going to have 1 pi over 6. So if K equals 0, it gives you one asymptote in pound 6. If you think about K equals 1, you will have 2 times 1 plus 1 pi over 6. So that gives you how much? 3 pi over 6. Okay. So you can see we talk about the distance between two asymptotes will be a period. So the gap between them. So from pound 6 to 3 pound 6, that is 3 pound 6 minus pound 6. That gives you how much? 2 pound 6, which is pound 3. Okay. And the period, as we know, period is pi over n. So if we compare pound n and pound 3, we know that n have to be equal 3. Now, that's one way to think about it. Another way is you can just, if you have the equation y equal a times 10 of nx, then the general solution for the asymptote can be written in general form as x equal 2k plus 1 pi over 2n. Okay, and if you compare these, they all have 2k plus 1 pi. So you compare, so you know that the denominator have to be 2n. So 2n equals 6, so n equals 3. That's how I know as well. All right. Then they give you a point. So you can sub it in and you can find I. Okay, so y equal a 10 of and x and is 3, make it 3k. So y equal 5, 5 equal a 10 of 3 times t is pound 12. Right? 3 pound 12 is pound 4. So what 5 equal a times 10 upon 4. 10 upon 4 will give you root 2 over 2. So 5 equal a times root 2 over 2. And as you solve for a, you times 2 over and divided by root 2. So you would have 5 times 2 on root 2 equal a. So you get 10 over root 2